So we are going to do the second experiment. We have prepared the soil, and the same soil we have prepared and sifted, we are going to use that for the second experiment. This experiment is called the shake test. Soil will deposit at different levels in the bottle, and we'll be able to see the different layers: sand, silt, clay. And we're going to read out the depths of each of these and convert it into a percentage. Right, so let's look at choice of, first step is choice of bottle. This one, although uniform, will not give me a good shake because of this, the shape of it. I will not get proper shaking with this. This one is uniform, it could be used, but I find this a bit, it's quite wide compared to the height of it. The material tends to stick at the top here. Alright? With this one, the mouth is a little wider at the top. It's easy to pour the soil in. My only reservation about it is the height, but it is a uniform bottle. If you look at it, it is uniform. I'm interested in uniformity and height, two things in the choice of bottle. You may use a bottle like a cherry brandy bottle, which is uniform and tall. The only issue with it is some soil tends to stick up in the neck of the bottle. So we're going to use this one for this experiment. First, I'll make an improvised funnel to get the soil into the bottle. Next step is I'm going to pour some soil into this bottle through the improvised funnel. Maybe a bit dusty, just be careful. Right, I don't want more than about 1/3 soil in this bottle. I don't want it too much because it will make mud. I'm not interested in mud, I'm interested in sedimentation. So this is approximately 1/3 or less. Alright, as long as I can get some measurements, I will use this amount of soil for this size of bottle. If you're using a cherry brandy bottle, do not cross more than 2 inches, approximately 5 centimeters. Next, I'm going to put water into this. Right, I'm going to leave a space at the top for shaking purpose. I have to cover it and shake it up and then leave it to settle for 24 hours before I do my readings. Right, so the next step is to cover it and shake it up. So I'm shaking up my bottle. Make sure all the dry soil at the bottom is thoroughly mixed up. I want all the particles in suspension. The heavy particles going to fall at the bottom first, then the less heavy ones, and then the very light ones at the top. And this way I will be able to separate the particles in the soil sample. Make sure it's thoroughly up in suspension. You need to leave a space for shaking at the top. Then I will put it down and leave it. Don't interfere with it for 24 hours. 24 hours after setting up the test, you come back to read your results. I notice there are 3 layers in this test. The bottom layer, which is hardly discernible, is made up of sand, the middle layer silt, the top layer clay. I'm going to take measurements of these layers. First I take the total height of the soil, and I see it is just about 3.0 centimeters. I take the height of the clay, I would say it is 1.4 centimeters. The height of the silt, 1.5 centimeters. Sand, 0.1 centimeters. We now have to calculate height into percentage. To calculate percentage, we use the formula height of fraction over total height multiplied by 100. We see clay is 1.4 centimeters, so that fraction of clay will be 1.4 centimeters over 3.0 centimeters multiplied by 100. I get a figure of 47%. Repeating the process for silt, 1.5 centimeters will give me a percentage of 50%. Sand, 0.1 centimeters will give me a percentage of 3%. The next step is to determine the soil textural type using the soil textural triangle. On the left of this triangle is the clay line, on the right is the silt line, at the base is the sand line. So we go from 0 to 100 sand, 0 to 100 clay, 0 to 100 silt. Since clay is 47%, we find that on the clay line and draw a line parallel to the sand line at the base. For the silt, find 50% and draw a line parallel to the clay line. Where both lines intersect, read on the soil textural triangle the soil textural type. The soil is a silty clay.